Okay, so I'm going to have an axis here, and then the second. Okay, so do this one both ways. Use both formulas that we now know. It's going to be 100 pounds this way, 100 pounds this way. We're given 15 inches back to A and 10 inches back to A on that one. Okay, so how would we handle this if we didn't know what a couple was? How would we handle this if we knew that it was a couple? Okay, I would probably say that this one is F1, this one is F2. What just happened? My moment of F1 is going to be equal to 100 pounds, and what is that distance from that far F1 to A? 15. And I have pound inch. And is that one acting clockwise or counterclockwise? Then I have another 100 pounds. That one is 10 away. And is that one acting clockwise or counterclockwise? Counterclockwise. Okay, so I do the sum moment about A. I would have negative 1,500 plus 1,000. I would get negative 500 or 500 pound inch clockwise. Okay, so that is option 1, like a moment. And then option 2, we understand it's a couple, right? We can see that if we do the sum of the forces in the y, we have a positive 100 and a negative 100 canceling each other out. That is a couple. And we should know the distance between them, which is 5. In between the two forces is going to be 5. So I'm going to have moment couple is equal to the force of 1 times the distance between the two, or 100 times 5. And so I get 500 pound inch. And looking at one another, is it going clockwise or counterclockwise? Clockwise. Taking it like a wheel. So there we go. Okay. So we're just going to do a couple more of these problems. I'll let you guys do one on your own. So this one, lots of different couples that we can see. They've nicely labeled them all out for us and kind of paired them. So we have F1 and F1, two opposite ends of this cheese curd, or probably a concrete block of some sort. Let's say it's cheese. Okay, they've already said F1s, F2s, and F3s. They've given distances between all of them. What they wanted to trip you up on is that F3 is 300 pounds and it's headed at some angle, correct? And they're given this 5 feet, okay? That distance is still the distance between those two forces that we're trying to figure out. It's angled funny, but it's still hitting both of those forces at 90 degrees, which is what we're looking for, okay? That distance has to hit those two forces 90 degrees, 90 degrees. Okay, so let's do the MF1. We know that it's 200 pounds. And what is the distance between the two? 3 for F1 here, and F1 here, 4. And are those going clockwise or counterclockwise? Clockwise. Okay, so it doesn't even ask from what point we're analyzing from, so that's kind of a tricky way of telling you that they want you to use these moment couples. F2, we have 450. And what is the distance between them? 3. 90 degree, 90 degree hit, 90 degree hit. did we get here? 1350. Clockwise or counterclockwise? Then we have 300. And the distance is, so we get 1500 clockwise or counterclockwise. So it's all the same thing, the sum of all the moments. I don't know my point, so I'm not going to put a little nomenclature down there. So I get 950 pound-foot clockwise. Okay, so the fastest possible way to do that problem using your moment couple equation. Cool beans. Okay, I'm going to have you guys do this next one. I'll come around and help accordingly. Determine which ones are the couples and finding using that second